Yeah, so my name is Robert Herring. I'm Executive Director here at the Washington East Washington Joint Authority. We are a sewer authority. We own and operate a wastewater treatment plant. We have 11 pump stations and a separate sanitary sewer system for the greater Washington area here in Western Pennsylvania.
Okay.
Yeah, so we are a point source discharger is how we're classified by the state. And basically what that means is we collect all this wastewater flow. Think of it like veins in your body where we have all the blood coming back to the heart. We're the heart with the treatment plant, right? And it's all coming in, and we have a single point where we discharge all of that flow into Chartiers Creek. So we are quite easy to regulate. Because you just grab a sample there where you discharge, and you can do whatever test you want to on that effluent. And so, in a lot of ways, we're easy to regulate because we're point source dischargers. The other broad classification of, pollutant discharge would be considered non-point source. And so, a non-point source is the opposite. It's a polluter who doesn't have a singular point of discharge of their flow. So farms are a great example. Farmers use fertilizers to grow more yield per acre of farmland, and when it rains, the water flows over the land and the crops and picks up some of that fertilizer and that nutrients, and it sheets over the land, or it goes down to the groundwater table, makes its way to the creek, which makes its way to the river, which makes its way into the Mississippi Delta or the Chesapeake Bay. And it builds up the presence of nitrogen and phosphorus in our water bodies. That's unfortunate because usually that's the limiting component for the growth of algae. I'm sure you've heard of algae blooms. And when this algae grows in shallow, clear water, it's got sunlight, it's got nutrients, it grows all this algae, and when that algae dies and starts decaying, it absorbs all of the oxygen in the waterway. So it creates dead zones for wildlife. So that's when fish and wildlife start dying. So it's an environmental problem. As a point source discharger, we can be regulated for the removal of nitrogen and phosphorus. However, the greater challenge and the bigger polluter is often coming from non-point source dischargers. They're more difficult to regulate. I brought up farms as one. Another common example, this wouldn't be nitrogen and phosphorus, but road salting programs. All the water that's on roadways, that's salt. So golf courses, another one. They're big water users, which is a problem in certain areas of the country. But also they're not called greens for nothing, and they use a lot of liquid fertilizers to keep their grass growing, and that has all the sheet flow contamination, just like farms do. And then obviously our grass yards. When people spread the beaded fertilizer all over the place. That can make its way to street inlets, make its way to streams, and contribute as well. Here in Western Pennsylvania, most wastewater treatment plants do not have nitrogen and phosphorus removal limits on their permit. We here at WEJA have monitor and report, so we have to measure and report it to the state, but we don't have quantifiable limits that we have to meet. And we've been reporting that data now for probably 4 to 8 years, and eventually it's going to result in a permit that contains quantifiable limits. And so even though the plant we're planning for may not need to do nutrient removal at the start, we want to make sure that it is capable and easily implementable to be able to do it in the future. Another example that's really coming down the pike fast are forever chemicals. So we just got added, so we're in the process of renewing our permit, and we just got a few forever chemicals added as monitor and report. So we're having to measure and report PFOS, PFOA, and a few other entities. And we're also having to test our customers' effluent, select customers that are known to have concentrations of forever chemicals, and do all of that reporting. So we're not dealing with quantifiable limits for that yet either, but it's obvious to see what direction things are coming. So right now our permit does not say, you need to be less than 1 part per billion of PFOA. It just doesn't say that. It doesn't historically hasn't known, and it's taken us a while to understand forever chemicals and that they're building up in the environment. That's part of it. The other part of it is the state doesn't want to implement concentrations too quickly or too fast, because you need the technology on the back end to actually be able to meet those limits. And when something's emerging, it takes a while for the marketplace to adapt and provide technological solutions for the removal of those contaminants. That's been another challenge. So basically what's happening right now is they're more or less pass through. We have a treatment plant that's not designed for the removal. Maybe things do get removed slightly just from our natural treatment process, but we're not targeting removal, and we're also not aiming. We don't have a target that we have to hit to get under either, if that makes sense. It is certainly the frontier, and every conference I go to is forever chemical this, forever chemical that. Even nutrient removal is a big one. Pharmaceuticals like endocrine disruptors, things like that building up in the environment, that's out there. Microplastics is another one that people are talking about. There's always going to be something new that is discovered, that there's going to be a push for better treatment. It's just the nature of the industry. So nutrient removal and wastewater treatment is really unique. We actually utilize microorganisms to uptake nitrogen and phosphorus. So what you do is you create anoxic, anaerobic, and aerobic zones within your treatment process. And it facilitates the growth of environments that require, we know the molecular process for nitrogen and phosphorus to be taken in as part of the cellular structure. And once it's in the cellular structure of the microorganism, you settle it out. You press it and you get the water out of it, and then you have we call it biosolid. It's like an organic cake, and all the nitrogen and phosphorus is in that cake as part of the organic material, as opposed to it staying soluble in water and being discharged out into the stream. It's a cool mix of like chemistry and technology and just can-do attitude, I love working on stuff that's kind of out of sight, out of mind. That's what I've always liked about infrastructure. I like that everything we own and operate is buried, and for the most part, people have absolutely zero idea how the system works. So it's like the opposite problem with the weather. The problem with the weather is everyone sees when it's raining and they have an opinion about this or that. But with sewer, it's just like magic. People take a shower, they flush a toilet, they do their laundry, and they really have no concept of how water gets conveyed and treated. And so it's fun. I find it fun to kind of explain and teach people the process, and also to have, to be involved with it, to make sure that we're being environmentally conscious and doing the right thing. It's not magic. There's men and women working every day in sewer systems and in treatment plants, making sure that we are responsibly treating and discharging our wastewater into the water bodies of this country. So I guess that's first and foremost. The American Society of Civil Engineers did like an infrastructure report card a few years. Across the board, infrastructure in this country is quite aged. Our wastewater system is no different. I forget the exact grade. It was like D or D minus they gave wastewater systems. That represents our facilities here at Washington, East Washington Joint Authority. Our treatment plant was built in the late 50s. The last major expansion or addition we did was in the late 90s, early 2000s. We have reused, modified, adjusted, done everything possible to keep it up and running. We're now in the stages of looking into actually installing, constructing a new treatment plant to replace our existing one and kind of set us up for the next 50 years. So I guess that's the other thing I would like to impart on people is that every once in a while infrastructure does need to be renewed, and unfortunately I think a lot of facilities are like us, where they're having to do those renewals right now, and where people feel that is in their sewer bills or their water bills or their gas bills or whatever it may be. And that's tough. It's tough to make that pitch, but there's certainly a need for it as well. Yeah, so it's really interesting, like when we're in the planning stages for our new plant. That's kind of the best way to think about it. We're not in detailed design yet. We're not submitting for permit applications for construction or anything. But when you're in planning, what you want to do is you want to make sure that you're walking down a path that resolves your issues of today and also is well suited to solve the issues of tomorrow. And so what we've had to do is take a really close, hard look at new and emerging contaminants that we're seeing in our environment. And we're having to make sure that even if we're not maybe able to treat for it today, that our layout is easily modifiable in such a way that we'll be able to easily implement improved treatment processes in the future. So I would like to see more. We're so reactive. We're reacting to problems once the problems already exist, but that's not the only way you could go about these problems. You could be proactive so that the problems don't even come into existence that you need to react to. And so, when you look at forever chemicals, how many different types of pans are there in the world? Do we need nonstick pans that are going to create forever chemicals that we're going to have to deal with for centuries? Or is that cast iron pan you inherited from your grandmother adequate, or that stainless steel pan? The amount of plastic we're seeing, single-use plastic, and how that's degrading down in the environment and causing problems. I don't know. I just feel like there's a lot of meat left on the bone in terms of being proactive about getting ahead of these problems before they become problems. I don't think that's necessarily the strength of humans sometimes. I think we're very good about reacting to problems and jumping to that and figuring out a solution. It's a lot harder for us, I think, to be proactive and avoid the problem to begin with. But it would certainly be nice. I understand the need for everyone to make a buck, but to have a little bit of foresight about some of the problems we're creating, I think would be appreciated on this side of the fence.
Like, what can we be doing? What can we be asking of, the people who are putting this stuff into the waterways?
Yeah, I mean, that's certainly a sore subject for wastewater treatment providers like ourselves. I mean, ultimately, we are receiving all of these waste streams and waste flows, but we are not the ones creating forever chemicals. We're not the ones creating microplastics. Yet we are the ones ultimately getting hit with more stringent effluent limits, more stringent permits, and we're the ones ultimately having to raise rates to help finance and pay for the technological and treatment upgrades required to meet those new limits, and we're the ones having to deal and address with all the customer complaints for, financial distress, and it's a sore subject. I mean, certainly it feels it can feel unfair, I think. With any of this stuff, it's a cost-benefit analysis in my mind. This is the United States of America. We are like the best at problem solving. We can fix any problem that comes up, but there's a cost to it. And it just becomes a question of what's reasonable. What can an average American pay for a sewer bill, and what can you accomplish with the revenues that result from that bill? Could every wastewater treatment plant in the country produce drinking quality level effluent? Yeah. Is it necessary? No. So it's about finding balance of how aggressive do we want to be? What is worth targeting? Why are we targeting it? What are the human health factors? What are the aquatic life factors? What's a reasonable approach to achieve an environmental quality that is that achieves the objective? I always like to grab onto the things that you can just implement without any high level amount of coordination with any third party agencies. And I think that there's a lot that can be done on the non-point source pollution side, just on the within the confines of your own property. I'll give my example as a house. We moved into our neighborhood back in 2014. One of the things we did is we installed some rain barrels that removed our roof leaders. So we lived in a combined sewer area. And so what we did is we removed our roof leaders, put it through a rain barrel, which detains that storm water. And then we routed that discharge hose, a perforated discharge hose, through our garden to help water it. And we put a valve on it so we could fill it up with water. And then whenever we want to water it, we open up the valve and we can water everything. So that's drops of water that aren't making it into combined sewer systems, not contributing to combined sewer overflows, and whatever other benefits there are to that. Another thing that's happening out in the world is there's a movement to get rid of grass lawns. We don't have a significantly large property, but in the back we kind of had this grassy area that really wasn't of much use. It was kind of a weird slope, and truthfully I was sick of mowing it, and so we decided to install a butterfly garden. So we figured out our native plants in the area. We stripped all the grass off. We put a mulch bed in this whole grass area. We planted native flowers that bloom all year round. So starting in the spring all the way through late fall, we get great flowers. We planted native milkweed species for the monarchs. When rain hits that, number one, it's not a fertilized area anymore. And number two is it's hitting mulch and twigs and debris, more natural processes that help filter that non-point source discharge. Other people are doing that as well, making wild yards that have more natural wildflowers and things like that. So I think that that's another step that individuals could do. In terms of bigger picture outside the boundaries of your own property, there's certainly organizations and nonprofits and charities who are looking to install riparian buffers. Riparian buffers have been proven to be a fantastic way to improve stream quality. So what they do is they look for water bodies, and they're looking for a strip of vegetation. I think they're looking for at least 100 feet deep or 150 feet deep perpendicular to the stream flow. But any amount is better than nothing. And within that riparian buffer, you plant trees, shrubs, you put fallen leaves, and whatever you can to filter the water as it travels through. And it's a great way to capture and filter out pollutants before they get into the waterways. I actually had to install a riparian buffer for a gravity sewer project I did, because we went through a high quality watershed, and we had to offset our impacts. And we found a property owner willing to give us land to install a riparian buffer on their property. But I know there's a lot of grant opportunities out there as well for people who have a lot of open farmland type areas. So that's a really effective tool for the non-point source discharge side of things.
Would you say that it stacks up in making a difference? Yeah,
we didn't do like the pre and post for our specific installation, but there's a lot of technical literature out there. And I mean, does there even really need to be? I mean, it's almost like common sense that, filtration of water through organic material is going to help clean up that water. That's activated carbon. Activated carbon is just organic material that you run water through, and it kind of filters it out and treats it. Nature figured out how to do all this stuff long before we came along. And so everything we do at our wastewater treatment plant basically steals from nature and tries to do it within the confines of a fence. And we try and do it in a smaller space than what is required to do it out in the world. And so, I mean, those are just some few things that people are able to donate, to find causes that support some of these initiatives. If someone gets a high sewer bill and they're pissed off, maybe have a little bit of empathy for that guy who's trying to do the right thing and reach, his effluent limits for what his permit has. I guess those are just a few things that come to mind, but there's certainly a lot of other things that could be done.